Hello, guys. This is Chanchal Jain, your chemistry teacher. I'll be taking your chemistry 11th classes. So, today we are going to start a very interesting topic, and that topic is from the very first chapter of chemistry, that is, some basic concepts of chemistry. And the name of the topic is on the next screen. You can see the mole concept. There is a beautiful diagram, if you can see, and that diagram shows a number, right? That is 6.02 into 10 raised to the power 23, right? If I'm not wrong, it is same as I pronounced. Okay. And the name is also given, that is Avogadro's number. Okay, it's Avogadro's number. So what is this number? Why this, this picture is here, and why the name is there? Who is the, who discovered this number? Everything, why we are concerned about this number in this chapter. Okay, so everything you are going to get the answers of every question in this topic itself, in this video itself. Okay, so the name is mole concept. The name of the topic is mole concept. Okay, and this term mole, it's very important. Okay, so I don't want to start with the boring lecture like what is mole, the definition of mole is this. So before that, let's go through a story. Okay, before the story, I just wanted to ask you a simple general question. Okay, tell me, what do you mean by 1 dozen? Tell me, what do you mean by 1 dozen? Okay, okay, whenever you go to a fruit seller, okay, and you ask for 1 dozen apple, so how many apples do you get in return? Okay, you are going to get 12 apples, right? Absolutely, you are going to get 12 apples. Okay, similarly, if you go to a bookseller and you ask for 1 dozen of books, then 1 dozen of books will going to, how many books will it be? It'll be how many? It'll be 12. Okay, so 1 dozen is nothing, it's 12. What does I mean by 1 dozen? It is nothing but it's just a number 12. Whenever you are going to ask somebody for 1 dozen item, he'll going to give you the 12 quantities of the item. It could be apple, it could be bananas, it could be books, it could be pencil, pen, anything, right? So it's just a beautiful number, that is 12. Okay, now why I'm telling you about this dozen, why I'm not coming on to the topic. So before coming on to the topic, uh before coming on to the topic, I just wanted to uh tell you something, that suppose he gave you 12 apples, right? That fruit seller gave you 12 apples. I'm not interested in the quantity, I want you to tell me that what is the mass of one apple. Okay, how does it weigh? Tell me the mass of one apple. Tell me the weight of one apple. Okay, tell me the weight of one apple. So I am just giving you the weighing machine. Use the weighing machine and just quickly tell me the mass. Suppose you have the weighing machine and you weighed it, and the one apple one apple weighs 100 grams. How does it weigh? How much it weigh? It weigh 100 gram. Okay, suppose there is one, you just bought grape. Okay, and I'm asking you, tell me the mass of one grape. Okay, and I just gave you the weighing machine and the weight, and I asked you, just tell me the weight of one grape. So tell me, is it possible for you to weigh one grape? No. What you do, in spite of weighing one grape, what you are going to do, you are going to weigh bunch of grapes. what you are going to do? You are going to weigh bunch of groups and you'll tell me, ma'am, the weight of these two bunches of grape comes out to be 100 grams. How much it came out to be? It came out to be 100 grams. Am I clear? So grape is a very small quantity, right? A very, very, very small quantity. So it's very difficult for you to weigh because you don't have the equivalent weight, right? So similarly, I just wanted to, okay, so similarly, when you're going to weigh the mass of one atom of carbon, you are going to get nothing. Okay, the quantity will be very less and it's immeasurable on the weighing machine. You cannot weigh anything on the, nothing will display on the weighing machine. Am I clear? Okay. Now, let's say that you have weighed 1 dozen of carbon atom. 1 dozen of carbon atom. Then also you got nothing. Okay. Then also you got nothing and the weighing machine showed nothing. It displayed nothing. Okay. Then whosoever performed this experiment, a scientist was there and he was doing these calculations and he was getting nothing. Then he just randomly took a number. And what is that number? 6.022 into 10 raised to the power 23 atoms of carbon. He took he just randomly chose a number and he weighed this number, these many atoms of carbon on the weighing machine, and surprisingly, he got the result. What he got? He got the result, and the result comes out to be 12 grams. What was the result? The result comes out to be 12 grams. Similarly, he just performed the same experiment for the hydrogen also, and he took 6.022 into 10 raised to the power 23 atoms of hydrogen, and he got the answer, that is 1 gram. Similarly, if I'll ask you that tell me the mass of 6.22 into 10 raised to the power 23 atoms of oxygen, then can anyone tell me the answer? Yes, it is nothing but it is 16 grams. Okay, from where these values are coming? How I know these values? These values are experimental values. They came experimentally, right? He performed the experiment and these values came. So if you have seen in the periodic table is in class 9th or in class 10th, there is a symbol like this, 6C12. So this 12 is nothing. This 12 is the mass of 6.022 into 10 raised to the power 23 atoms. So you can relate it. Now you can relate it from where these values are coming and why they have put it them like this, 1H1. For oxygen, it is 8O16, right? Okay. Now, if I'll ask you, that tell me the mass of one atom of carbon. So I think you can now do it. Okay. So weighing machine will not going to show anything, will not going to display anything. All right. But now with the unitary method, we all know the unitary method, right? So we all know the unitary method. So we can go and what we can with the unitary method, one atom of carbon weighs 12 multiplied by 1 upon 6.022 into 10 raised to the power 23 and grams. Okay. What did weight? It weighed 12 into 1 upon 6.022 into 10 raised to the power 23 gram. Similarly, if I'll ask you for the hydrogen, what is the mass of one atom of hydrogen? Then you know the answer. It's 1 multiplied by 1 upon 6.022 into 10 raised to the power 23 grams. Similarly, if I'll ask you for the oxygen, I think you can tell me now. Tell me what is the mass of one atom of oxygen? Tell me. I'm just waiting for your answers. It's, ma'am, it's nothing. It's 16 multiplied by 1 divided by 6.022 into 10 raised to the power 23 grams. Right? Right? Okay, let's go back. Now you can see that in these three slides. Okay, if you can see the similarity in these three slides, then what is the similarity in these three slides? This number, this quantity. Okay, this is similar. This quantity is similar in these three slides. The quantity is 1 upon 6.022 into 10 raised to the power 23. Okay, so what is this quantity? Grams. What is this quantity? This quantity is nothing. This is named as AMU. This is named as 1 AMU. That is, what does AMU refers? AMU refers to atomic mass unit. Okay, in order to compact the mass of one atom, in order to compact the mass of one atom, they just named this quantity because this quantity is common for every element, right? I'm multiplying by this quantity, and this quantity is common in all the elements, so I have named this quantity as one atomic mass unit. Okay, so 1 AMU. So if I'll go back and I'll ask you that, tell me how am I going to convert them, then one atom, mass of one atom of carbon is nothing. You can write it as 1 AMU. What is the mass of one carbon atom? It is nothing, but it is AMU. It's 12 AMU, 12 atomic mass units. If I'll ask you the same for hydrogen, then the mass of one hydrogen atom is nothing. It's 1 AMU. And if I'll ask you the same for oxygen, then it is nothing. It is 16 AMU. The mass of one oxygen atom is nothing. It is 16 AMU. Now, why this number is so special? Okay, so who discovered this number? Who performed the experiment? We are just talking about the experiment only. We're not talking about the scientist who performed this. Okay, so the name of the scientist is Avogadro. What is his name? His name is Avogadro. He performed the experiment and he found this value 6.0221415 into 10 raised power 23. As approximation, we take it as 6.022 into 10 raised power 23. You can use this as well. This is okay. Now, Avogadro. So this number, in order to honor that scientist, this number is also named as Avogadro's number. Okay, this number is also named as Avogadro's number. Am I clear, everybody? I think till here you have understood. Okay, it's Avogadro's number, right? And there are some symbols are also there. Okay, some symbols are there, and this number is symbolized as Na. Okay, A is the subscript for the name of the scientist Avogadro, right? And N is for number of atoms, so it's Na. Okay, so the number, you can just symbolize this number as Na, and the name of the number is Avogadro's number. And the very, very important thing is that this number is also known as, you can call it as 1 mole. What is this number? This number is nothing. Just as you call 1 dozen equals to 12, so here you have you have the name of this number, that is 1 mole. You can name this number as 1 mole. So 1 mole contains how many quantities? It contains 6.022 into 10 raised to the power 23 quantities. Am I clear, everybody? Till here everything is clear? Tell me, I can repeat it for you as well. I can repeat it for anybody. Okay, so till here everything is clear? Okay. Now, suppose I asked you, tell me 1 mole, um, 1 mole books. So you tell me, how many books do I get? Tell me the answer for 1 mole books. Ma'am, it is nothing. You are going to get 6.022 into 10 raised to the power 23 books. How many books do you get? You are going to get how many books? It is nothing, but you are going to get 6.022 into 10 to the power 23 books. Similarly, if I'll ask you, I'll have 1 mole oxygen atom. Then how many atoms do I have? I have 6.022 into 10 raised to the power 23 atoms. Is that clear? Okay. Suppose I'll ask you, if I have 1 mole of water molecule. If I have asked you for 1 mole of water molecule, so how many water molecules do you have? You have 6.022 into 10 raised to the power 23 water molecules. So is that clear, everybody? So what is mole? It's clear. What is the what is the meaning of mole? Is it clear to everybody? What do we mean by mole? Is it clear to everybody? Okay. So we are going to end this lecture over here only. And tomorrow we'll do some calculations on this mole. We'll study the technical definition of the mole, and also we'll perform some numericals on the moles. Okay, we do have different formulas to find the moles of the respective atoms, molecules. Okay, so we'll go with that. Okay, so rest is, if anybody has any kind of doubt, tell me. I'll just clear it now only. Okay. Bye bye, all of you. Thank you so much. We'll meet tomorrow. Bye.